For the second homework, we're given 4 equations. We're asked to find the inverse Laplace transform. These are in the form f of s is equal to some fraction. For number 1, it's s squared plus 1 over s squared plus s plus 2. And so we have to use partial fraction expansion to solve these. So let's go ahead and start with the first one. So for number 1, looks like we have real roots on the bottom, and it looks like that they are repeating. So this is going to be a real repeating root problem. So we can break up the fraction and put it in this form. a1 over s plus 2 plus a2 over s plus a3 over s squared for that repeating root. Cool. So I'm going to show y'all a method that makes things a little bit easier for problems like that, and it's called the cover-up method. So the way the cover-up method is, we can cover up something in the denominator here to try to find the coefficient associated with that part of the denominator. So for example, if we want to find a1, what we can do is we can cover up the s plus 2 on the denominator, and then we set s equal to what that corresponding root was. So the corresponding root for s plus 2 is negative 2. So if we cover up s plus 2, and then we set all the other s's equal to negative 2, that gives us a1. So let's do that for a1. So we have s squared plus 1 over s squared is equal to a1 if we set s equal to negative 2. So we covered up the s plus 2. So if we plug all that in, that comes out to 5/4. So I have negative 2 squared plus 1 is 5 over negative 2 squared, which is 4. So that's really easy. We can just pull out a1 like that. Cool. We can't do a2 because there's no s really to cover up. We can do a3 because we can cover up the s squared. So if we cover up the s squared on the denominator, we end up with s squared plus 1 over s plus 2 is equal to a3 when s is set to 0, because the root of s squared is 0. So if we do that, this term goes away, we end up with a 1 here, this term goes away, so we just have a 2 here. So that's equal to 1/2. 1/2. Cool. So right off the bat, we found 2 of our coefficients, like without even having to do any serious algebra. We're going to multiply everything out to find a2, but we already know a1 and a3, so that makes that even so much easier. So what we're going to do is we're going to multiply out the denominator throughout everything, and then we'll hopefully try to find a relationship between a1, a2, and a3 in that equation that we can use to pull out the real value of a2. So if we multiply everything out, we're going to end up with s squared plus 1, because our denominator went away, is equal to, now the s plus 2 on the bottom of our a1 right here is going to cancel out with that s plus 2. So we'll just have s squared times a1. And that's going to be plus. So same kind of goes here. We're going to end up with s squared plus 2s times a2. And then we're going to have s plus 2 times a3. So we can multiply everything out further and gather our like terms, and hopefully that'll give us a relationship. So if we want to gather our s squared terms, we have s squared a1, s squared a2, no s squared over here, so I'll write a1 plus a2 times s squared. For s, it looks like we have 2s times a2 and then s times a3. So we'll write 2a2 plus a3 times s plus, and it just looks like we have a 2a3. Okay. So let's see, there's a couple easy ways to do this. Looks like one relationship we have here is 2a2 plus a3 is going to be equal to 0 because there's no s term over here. So we don't know what a2 is, but we do know what a3 is. So 2a2 plus 1/2 is equal to 0. So that means that a2 is equal to 1/4. We also could have looked at, okay, a1 plus a2 is equal to 1. So we know that a1 is 5/4. So that would have meant that a2 is equal to -1/4. Looks like we might have missed a sign here. Let me check the manual. Let's see. Oh yeah, of course. That's going to be, in order for that to be true, that has to be -1/4. My bad. Because that would have been equal to 1 if that was 2 times 1/2 plus, or 2 times 1/4 plus 1/2. It needs to be 2 times -1/4 plus 1/2 is equal to 0. So our a2 is -1/4. That's the same as if we did 5/4 plus -1/4 would be equal to 1. So let's go up here, write our -1/4. Cool, so we've kind of got our equation written out. Let's go ahead and write it out and do the inverse Laplace transform. So I'm going to get a new sheet of paper. So if we multiply everything out, we end up with 5/4, 1 over s plus 2, plus 1/4 times, it's going to be -1/4 times 1 over s, plus 1/2, 1 over s squared. Cool. So once we're at this point, now it's just a matter of looking at our Laplace transform table. So let's see, the 1 over s plus 2 is going to turn into, so 5/4 e to the -2, because that's our a/t, minus, so 1 over s that's just going to become 1/4. And 1 over s squared is going to turn into t, so be 1/2 t. And all this, of course, unit step function. Alright, that should be the answer. Not too bad. Definitely more complicated than the first homework. But this is kind of the nitty-gritty Laplace transform stuff that we're kind of supposed to get through anyway. So this will be the sort of thing that'll be on the test. Not a huge deal. Once you work a few, it kind of becomes straightforward. So, alright, I'm going to go make a video for the next one.